Hello everyone, I'm Samya Ravi and I'm going to be presenting a video on commercial detection based on short changes. So we'll start off with why we're doing this. To see it from a viewer's point of view, it'll save up a lot of time and memory if you remove a particular commercial from a recorded video. And also it can be used as a tool for censoring. And to see it from a seller's point of view, it can be used to check if the terms and conditions of a contract has been fulfilled, and also for checking if the particular commercial is being broadcasted at the right time. And the classification of detection scheme is done into two. One is a feature-based detection, where the general characteristics like insertion of the black frame, silence, region, and the scene changes, etc., can be used for detecting a commercial. And in the recognition-based detection, we identify the individual commercials by matching it with the ones that are already stored in the database. And we can use features like captions, logos, slogans, etc., for detecting the commercial. And the characterization and the detection key are listed as follows. And the many characteristics of a commercial that can be used for detection. To name a few, we have like the black frame insertion, the network logo at the corner of the frame, the caption recognition, average short time energy, then keyframe recognition. The one that I'm going to be concentrating on is the action-filled advertisement, where the advertisers, to make the advertisement look more appealing and to gain the attention of the viewers, they add in many more scenes within the given frame. So we have defined two parameters for finding the number of scene changes. One is the cuts and the strong cuts. The cuts is basically the number of scene changes or the short changes in a minute, and strong cuts is the same as cut but with a higher threshold for dissimilarity. And we can find the dissimilarity or the similarity by two ways. One is the pixel change and another is the color change. In the pixel change, we take the pixel intensity in one frame and compare it with the same pixel in the next frame, and if the difference is high, we will say that there is a pixel change. And the measure of similarity can be found by this parameter and is given by this formula. And there are disadvantages to the scheme of detection. One is that this one is sensitive to luminance change, and the parameters again sensitive to camera motion such as zooming or panning. And the second one is the color change, and instead of using the pixel intensity, we use the color histogram. And it can be we find this parameter called the color histogram difference, and it can be found by using this formula. Here h of I represents the color histogram of the ith frame, and if we had to compute it for each color channel. And we say that there is a scene change if the color histogram difference is high. So we have to define cut and strong cut. We say if the amplitude of the color histogram is greater than 25, then we define it as a cut, and if it is greater than 50, we define it as a strong cut. And it can be implemented as follows to find the color histogram difference. So first we have to read the video. After reading the video, I have to store these different frames of the video in a MATLAB path, a file in a MATLAB path. And for each of these frames, you have to segregate it into three color channels, that is R, G, and P. And for each color channel, we have to find the mean. And after finding the mean, we have to compare it with the means of the previous frame. And whatever difference we get, we have to compare it with the threshold. And if it exceeds the threshold, we say there is a cut or a strong cut in the video. So color histogram difference plot for typical commercial can be as seen in this plot over here. And as you can see, there are many spikes in the graph, and the region wherever there is this spikes is the place where there is a short change. And you can see that the mean of all the different color channels is almost comparable, except for few areas like here where there is a big difference. and the results are tabulated as follows and is divided into two cases, that is case 1 for commercials and case 2 for non-commercials. In case 1 we can see that there are the cuts and the strong cuts are pretty much high for ads or the commercials, and it's greater than 25, and strong cuts are greater than 15. There are a few special cases where this criteria is not met, and we'll talk about it later. So this is color histogram for one particular case where there's so many spikes in the video. As I mentioned earlier, the few special cases, and one of them is ad 4, where the ad 4 where the number of strong cuts is lesser than what it's supposed to be. So let's take a look at this video. So the number of cuts are many, but the color changes is not that significant. I mean, there are color changes in the video, but it's not very high. The difference is not very high. So the cuts is high, but the strong cuts is lesser than what it's supposed to be. So this ad does not meet the criteria that we have defined. And if you compare it with some other ad that does meet the criteria, you'll see that the cuts are high, just like ad 4, but the color change will also be very high, like the color change between this frame and this frame, this frame and this frame. So the strong cuts for this video would be pretty high, not like ad 4. And for case 2 for non-commercials, again cuts should be lesser than 25, and in most of these cases the criteria is met, and the strong cuts should be lesser than 10 or 15, and the criteria is met again, except for a few special cases. This is a color histogram difference plot for a non-commercial. As expected, there shouldn't be many short changes or cuts defined, and this is this ad meets the criteria. So if you check this table, we notice that for ad 2 the number of cuts is 34, that is way higher than what it's supposed to be for a not commercial. If you take a look at this video, we notice that there are many cuts in this video, like here. So the number of short changes increases a lot over here. So the cuts is pretty much high, and if you go towards the end of the video, say from here, the short changes, the scenes are not changing much. So towards the end, the cuts is pretty much low. So this is a plot for that particular non-commercial. The number of cuts at the very beginning is very high, and towards the end it's pretty much 0. And also ad 5 does not meet the criteria. It has cuts, a number of cuts is 29, and the number of strong cuts is 13. It's pretty high. This is a particular video of a movie. It's a trailer of a movie. So it's an action movie, so the number of short changes in the movie is going to be high. So that's the reason why few of the non-commercial could be detected as a commercial. And I also did a comparative study of the old commercial versus new commercials. I took the same brand advertisement, and over the years the strategy that they used has pretty much changed a lot. In 1950s the number of cuts was very low, but towards 1990s the number of cuts had increased tremendously. So this represents a few drawbacks of the system. And say if you have a recording for 1 minute, and for 1 minute is 60 seconds, and if you use the 30 frames per second video, then we would have 30 into 60 frames totally, and processing 1800 frames will be very time consuming. And the system is not obsolete. As I said, the strategy that can be used by the Advertiser can change at any point of time, so we have to keep updating the system, and after a point of time it's going to fall down, and it's not 100% accurate, as we already said in case 1 and case 2. So we need few methods of improvising it. One way we can improvise it is by combining it with another system. So we can use the average short time energy. I basically chose this because it's very computationally efficient, and it is less time consuming, and the average short time energy of an audio of a commercial will be much higher than that of a non-commercial. Using this strategy, we can detect commercials and non-commercials in a much more efficient way. So that brings us to the end of this presentation. Thank you.